Alright guys, so I made a dumb mistake, but it's worth pointing out for anyone that's gonna follow in my footsteps. You need to know this so that you don't make the same mistake. Okay, so the differential, the center diff, it's got bearings top and bottom, right? I thought, what the heck, why not try and take the bearings off? So this one is not that hard to take off. This one on the bottom I think is not possible. I don't know, maybe there's a special tool, but like, how do you get a tool under there to get to that surface when it's, I don't know. I don't think you can get that bearing out. So I spent like an hour on the phone with the Subaru parts dealer down, the local shop, and I finally found these bearings and ordered them. I ordered two because I didn't think I'd be able to get this guy off, but I was able to do it. I'll show you how in a minute, but the dumb thing I did was, okay, so I ordered the limited slip diff, which I think everyone should be ordering, because why would you not want that in your expensive transmission? But that's another topic, I suppose. So I wanted to see how the stub axles fit and see if I could turn the helical gears over. So I went to my parts bin and I grabbed the bag with the stub axles in it, and looky there, of course, it's a brand new set, bearings and races, same part number, everything. So don't need to save that race or the race that's in that one. I'm going to use the brand new bearing and brand new race, but there's still a set of parts ordered down at the Subaru dealership. So that's annoying. Don't do that dumb mistake. Make sure you don't have it in the bag ready to go and waste all your freaking time trying to pull one of these off to save a little bit of money. So anyway, if you do decide you want to pull these off, I found two sets of pliers that were just the right size to where they would sit under here, right? And it would put the shoulders of the bearing onto the sides of the handle. And now you're just going to have to imagine that I'm holding the entire differential assembly in the hand here with this wrench. And I set the thing like so on the open jaws of the vise with the differential hanging straight down. So the weight of the differential was hanging down. This bearing is lower profile, doesn't stick out like the edge of the housing does, so that left a nice surface to hammer on. So the differential was hanging in my hand with the wrench holding the underside of the bearing. You tap on here, the differential wants to drop out. So I don't know if it helped or not, but I used a bead of penetrating oil on the top there and let that sit for a while. And I also heated the outside edge, not a whole lot, but enough to make it warm. So I don't know if the combination of those things made it easy to pop off, but that's what I did. So if you do decide to pull those bearings off, well, sorry, that bearing off, that's one way to do it. And then once it got big enough, I used the end of the wrench and just ever so slightly went around corner, all four sides, and just slowly and gently prying it up. Not like torquing it to get it way out of whack, but just ever so slightly, gently pulling it up and out. So that's how I popped it off. But yeah, I'm not going to use that. I'm going to try the good old put this in the deep freezer and put one of those in an oven at, I don't know, 300 Fahrenheit, something like that. See if I can get them to drop on. Once I get the bearings dropped onto this, I'm going to start double checking the clearancing on that. Pop those races out. We don't need those. Gonna put the new ones in. Once it's clearanced, take that shaft, put it over there, and set the backlash and start checking gear patterns. I was able to track down the part numbers for these shims, and looky here, something I didn't see before. There's 2 shims in here. They have like, I don't know, 10 or 12 different part numbers for different thicknesses of shims. I tried calling a few different Subaru dealerships. One dealership was super not helpful. The other dealership was way more helpful, and they worked with me, and they said, okay, we got like 8 of them that we can ship out today, and you know, like the other 2 are going to be a week delayed. And so I was like, well, given that I've got these 2 and you can add and subtract shims to change the thicknesses to what you want within reason, I was like, just send me those 2. Or send me the 8 and forget the other 2. I'll get them later if I need them. So once we got that, we should have no trouble getting the gear wear pattern set up. Now, something else that I've been working on, so this is kind of neat. So in my previous video, I walked through the... Wait a minute. No, I didn't walk through it in my other video. This is all new stuff. So I've been experimenting with how to mill out an oval-shaped pocket. And this is my tester piece, right? This is the small piece of copper tube, 1/8" plate. This is not the final product. However, it's a proof of concept. And that concept was 3D print a guide. Now, this guide is equipped with almost a dovetail, to where you bolt down the main plate and then you slide in and out different tools for different operations. So what operation, you might say? You can mill aluminum with a router. If you are slow and careful, take small steps. So this guy's got a 1/4" collet. So I've got I think it's like a 3" long, 1/4" end mill 3 flute. And yeah, so you just stick it in to where the depth of the cutting teeth is below the depth of the plastic. You oil up the surface that the not sharp portion of the end mill is going to be running on, the shoulder, whatever you'd call it, right? And yeah, it rubs on the thing. I mean, there's a tiny little gouge, but the bulk surface is still there, no problem. Dimensionally very accurate for something like this. I mean, so this is still prototyping, so a current problem that I'll need to solve with the next version is that little gap right there. So for this version, I didn't care because it's proof of concept. Can you mill it? And then not only can you mill it, can you braze it together with the appropriate brazing compound? So let me try and get you a good angle of the radius on that. Oh, come on back. The radius on that fillet. So I am by no means a brazing or welding expert. I was taught probably 7 or 8 years ago when I was in college. And this is my first attempt at really brazing since then. This is the stuff I used. Lucas Millhout AL822, specifically made for joining copper to aluminum or aluminum to aluminum. It's kind of a lower temp braze. Yeah, I'll have a whole video going through that when I start putting those together. Yeah, so, however, dimensionally, oh, not that one. Dimensionally, this thing was super accurate. And given that the 2 metals are pretty soft, you can kind of lay it on its side here and gently tap to close any gaps, and then obviously that brazing bead does the rest of the sealing. So this is proof of concept. The concept is I don't have the money to buy a Bridgeport, so I'm making do with 3D printed jigs and a friggin' router. So we're gonna have a video going through that for that guy, and I'm really, really excited about that. I just wanted to throw this in here as a little teaser, and this is what's coming. I want to be able to teach people how to make complicated parts with cheap stuff. My 3D printer was shipped to my door for 170 bucks. A router, what is that, 80, 100 bucks, something like that? With those two, you can make really complicated parts, right? So with this special jig, bolt that guy down, you can slide just about any shape cut you want in there, or angle. You could angle this plate so that you're coming in at an angle, right? Or the other way, doing a pocket, right? So the limits of what you can do with this is really your imagination. I kind of call it like an analog CNC, because you're following a set tool path, but it's all done by hand. I mean, I can't wait to show you guys. It's so cool. Basically, come here, router. The router just sits on the top here. So the bigger your printing, your surface that this guy sits on top of, the better it's going to be, right? Because you don't want to be tipping away. But as long as you keep good even pressure and you work slow and you take tiny cuts, this thing is like amazing. I just can't believe how well it works. So we're going to call that good for now. Here's your little teaser of what's to come. Don't be dumb. Check through your parts. Make sure you don't have what you already need before you waste all your time. All right, that's going to be it. See you later.